Okay. Here's the next one. So this one is this is a product rule, x squared times the cube root. So we are going to have to use the chain rule eventually, but it is a product. Product says you take the first times the derivative of the second. So before I do that, let me rewrite this. First times the derivative of the second, which, following the chain rule, is 1/3, leave the inside alone, x cubed minus 6 to the negative 2/3, times the derivative of the inside. The derivative of x cubed minus 6 is 3x squared. Plus, finishing the product rule, the second times the derivative of the first. Now, you may want to, at this point, just make sure you did everything correct, because it's always easy maybe to forget like this square, or forget to take the derivative of the inside, or whatever. So now I'm going to multiply everything together, clean it up. This is the cleanup. This one's going to clean up nicely because we have a 3 times a 1/3, so that's going to eliminate fractions. That should make the simplification a lot easier. We have an x squared times an x squared, which is x to the 4th. So that doesn't look too bad. The next term, there's nothing to do, except, as I like to do, write this single term in front of this binomial. And now I'm going to look for the common factors. Obviously an x to the 1st. And then also, obviously, I hope, is an x cubed minus 6 to the negative 2/3, because that's the lower of the two exponents. So we are going to factor that out. X times x cubed minus 6 to the negative 2/3. And write down what's left over in each of these two terms. Well, I factor out an x from x to the 4th, so I'm left with x cubed. I factor out this entire x to the negative 2/3, so it would just be like a 1. This doesn't look very good. That's a 3 times 1. And then from here, I factor out the x, so I'm left with 2. And this 1/3 plus 2/3 is 3/3, or 1. So this is 2 times x cubed minus 6 to the 1st. So now I'm going to go ahead and simplify everything in here by distributing that 2 and then combining. So I'm going to combine all of this. I'm going to bring the x cubed minus 6 to the negative 2/3 to the bottom, and hopefully I'll have a final derivative. X cubed plus 2x cubed is 3x cubed minus 12 all over x cubed minus 6 to the 2/3. So now that I did that, I can see there's one last thing I can do. There's a common factor of 3 in the top, so I'm going to factor that out. And here is my final simplified answer. So oops, I forgot that x. That could have been deadly. Stay tuned here, because I'm going to show you a check on the calculator, and it's going to be slightly different. You may want to use it. So, as always, on the calculator, I'm going to type in, as you can see, the original function and calculate the derivative. Now, it is a cube root, but you can see that it's something going on here. So I don't want to pick that value for the derivative. Let's take the derivative at 3. So second calc, 6 for derivative, at 3, enter. 27.195. So write down that number, 27.195. Now, type in 3 into your derivative. Here's the slight difference that I haven't shown you before. Some of you may like this better. It may be easier for you to type it in. If you just type in your answer like this, and this way I know I've typed it in correctly, and hit enter. I have 27 point, well, I got lucky. This was a bad example. That looks like the right answer. But what you need to do is, I was expecting this answer to be wrong because the calculator has an X stored in, whatever I stored in last. So if I say I hit X, enter, it shows me X was 3, and that's exactly what I plugged into the calculator. So I got lucky there. Make sure you redefine what X is. In other words, if X was defined to be 4, so you hit 4 and then the store into X, and then retype in your expression, it will give you the value of the derivative with 4 in it. So this is most likely what would happen when you just type in your answer. Now I want to make sure I'm doing it at 3, so now I can just hit, well, let's make 3 stored into X like it was originally. I'm sorry that happened, but it did. And now if I re-enter my expression in, it will give me the value of this expression at 3 because the calculator now thinks X is 3. So it's just a quick way maybe of, maybe a quicker way if you agree to type in your answer to the calculator. But nonetheless, this did agree with what the calculator gave me, so I think my answer is correct.